Hello, welcome to Get Academy Global. In this video, we are going to discuss the solutions of test or assignment 2, and the syllabus for this test was the topics that we have covered till lecture 6. I hope you have enjoyed the test as the questions was not too tough, but it may seem tricky. So let's start with question 1. And the first question, it is given as, you have to find if x of t is equals to del of t, then the area under the function. It is given that signal x of t is impulse function del of t, then you have to find out the area under the function yt, that is given as summation from k is equals to 1 to infinity x of t upon k. So what I really want is, I want to see you playing with the signals. So if any of you have doubt that if there is an impulse at t is equals to 0, what will happen if we add up the impulses at t is equals to 0 of different amplitudes, or you can say different area. It is not amplitude, it is area. Then what will happen? So it is a simple question, it is very easy question, and I hope you all must have attempted it. So the value, if we see, if we substitute x of t is equals to del of t here, then the y of t is equals to summation from k is equals to 1 to infinity del of t upon k. So let us see first from the property of impulse function. We have seen the time scaling property, that if there is del of alpha t, then it is equals to 1 upon mod of alpha into del of t. So at the place of alpha, here we have given 1 upon k. Therefore, by the similar rule, del of 1 upon k times t, it is alpha is equals to 1 upon k. The value will be 1 upon mod of 1 upon k into del of t. Is it right? So what we can write it, del of t upon k is equivalent to, it is 1 upon k, therefore it is k times del of t. So if we substitute this value of del of t upon k in this value y of t, then signal y of t is summation from k is equals to 1 to infinity. It is actually 1 to 15, we have taken here 1 to 15, otherwise the sum will be infinite. Here it is 1 to 15, so I am changing the limits 1 to 15 here. So the value is summation from 1 to 15, and it is k times del of t. So this del of t term is independent of k, so you can take it out, or you can expand this summation y of t. So what you will be getting is, put from k 1 to infinity, therefore it will be 1 into del of t plus 2 into del of t plus 3 into del of t up to 15 into del of t. So you can take del of t common, and you will be having the series of 1 plus 2 plus 3 plus 4 up to 15 times it is del of t. So simply, if you have to find out the area of this signal, if y of t, you can see here, y of t is an impulse, and the term written behind the impulse will simply give you the area of that impulse. Therefore, the area of signal y of t is nothing but the sum from 1 to 15. And you know that if there is s, that is equals to 1 plus 2 plus 3 plus up to n, then this sum is given as n into n plus 1 divided by 2. In this case, you are having n is equals to 15. Therefore, you can say that the area of signal y of t is equals to 15 into 15 plus 1, that is 16, divided by 2, or it is 15 into 8, that is equals to 120. So most of you students will definitely get marks in this question. So the for first question, the correct answer is 120. It was a numerical answer type question, so if you have mistaken, then still there is no problem, you don't have any negative marking for this question. So the next question, question number 2 is, the value of y of t, we have to obtain the value of y of t, that is cos of 2 pi times t minus 4, it is t minus 4 upon 2t plus 6 times del of t minus 2. So again, this question is based on properties of impulse function. You know that if there is signal x of t multiplied with impulse del of t, then this product results again in form of impulse, that is del of t only, but the area of this impulse will be the value of this function x of t where this signal is existing, and as this signal is existing only at t is equals to 0, therefore the value of this signal x of t at t is equals to 0 is represented as x of 0. Similarly, if you have x of t multiplied with any shifted impulse which is not occurring at t is equals to 0, then the value of this product will be the impulse, this same impulse del of t minus t naught, but now you will have to find the value of this signal x of t where this impulse is occurring, that is at t is equals to t naught. Therefore, you write the value x of t naught. So now if you see the question, we have to find out the value of y of t, where if you select this signal as any signal x of t, if you consider this part as x of t, then this signal y of t is defined as x of t into del of t minus t naught. Therefore, you can say that the value of t naught is 2. So if t naught is equals to 2, then for this value y of t is equals to value of this signal cos of 2 pi times t minus 4 divided by 2t plus 6 at t is equals to t naught, that is t is equals to 2. But you must have to write the impulse with it, because there is no integration included in this signal y of t. If there will be integration from minus infinity to infinity or integration from 2 minus to 2 plus, then the value will be this part only. But as the integration is absent here, so by the product property, you must have to write the impulse, that is del of t minus 2. Therefore, in this question, if you have seen the options, then there is no need to solve this question, as 3 options that are numerical, you can say numbers, as 0.1 or minus 0.1 or anything, but impulse is missing with first 3 options. Therefore, the option must be option D, that is none of these. So if you evaluate, if there will be the integral sign also, then what will be the value of this term at t is equals to 2? It will be t 2 minus 4, that is minus 2. Therefore, it is cos of minus 4 pi divided by 2 into 2 plus 6. So cos of minus theta is cos theta only, and cos of 4 pi is 1. Therefore, this value would be, but here it must be included del of t minus 2 also, but the value of this, you can see that it is 1 upon 10, that is 0.1. So the correct answer would be 0.1 times del of t minus 2. As the impulse is absent in all the options, therefore the correct option for this question number 2 is option D. Now, the next question, these all concepts you have seen in live lectures. In this test, in the syllabus of this test, we have included one more topic, that was even and odd signal. As I can expect that you must be familiar with this topic, as it is the most basic topic. So, in question number 3, here we have given, if g of t is a generalized function, given that g of t is a generalized function. So, what we have to find? It is also given that the area under this generalized function g of t, area, and how you find out the area? If you have to find area under g of t, then you must have to integrate this function gt dt from minus infinity to plus infinity for the duration in which this g of t is occurring. So, given that this area, the value of area of g of t is also given to you as 4 square units. So, now you have to find out the value of integral, that is I is equals to integration from minus infinity to infinity. It is 13t times g dash of t dt. So, in the last live session, we just have seen the properties of generalized function. Let us recall one more time. You have seen that a function is said to be a generalized function if there is a point of singularity at which this function cannot be differentiated. Therefore, if the differentiation of g of t is not defined, then we defined it in terms of other function. Any function, let we have taking any function x of t that is continuous at t is equals to 0, then you write integration from minus infinity to infinity g dash of t into x of t dt. You have to define the value of differentiation of generalized function, then you use the result. It is equals to integration from minus times integration from minus infinity to infinity x dash of t into g of t dt. So, you know this fact. From the similar result, if you generalize the result, if we are taking the first order derivative, then we are using 1 minus sign, and here x of t is differentiated one time only. If you take in general nth order derivative of a generalized function, then from the same result, integration from minus infinity to infinity g n of t, this g n of t represents the nth order derivative of generalized function gt into x of t dt, where x of t is continuous at t is equals to 0, then it is equals to minus 1 to the power n integration from minus infinity to infinity x n of t into g of t dt. That is nth order derivative you will have to take of the signal that is continuous at t is equals to 0, and then you must have to take the product of this function with generalized function. And here minus 1 to the power n will be the term. So if we apply the function, that result here, let it is any function x of t, let it is x of t, then the given integral is x of t into g dash of t dt, and it is equals to integration minus sign, integration from minus infinity to infinity, x dash of t into g of t dt. So we have to find first order derivative of this function x of t, and if you differentiate 13t with respect to t, then you will get 13, and that 13 term can be taken outside the integral. Therefore this integral I becomes minus, you have taken 13 out, that is the value of x dash of t. Now you are left with integral minus infinity to infinity g of t dt. And now this term is nothing but the area under function g of t, which is given to you as 4 square units. Then the value of integral becomes minus 13 into 4, that is minus 52. So this was also a basic question. You must have an idea about this question and you have solved it correctly. So it is numerical answer type question, but there will not be any range for this question as the answer is perfect integer. So for question number 3, the correct answer is minus 52. Now move on to question number 4. In question number 4, I just want to include some part of aptitude, or you can say reasoning. So here we have given that in a code language, rectangular terms, rectangular is used for, here is given that rectangular word is used for even. Rectangular represents even. Next, meaning of width and amplitudes are interchanged. Wherever we use width, it means we are trying to say amplitude, and wherever we write amplitude, it means it is width, amplitude. So width and amplitude meanings are interchanged. The next value, here interchange impulse word is used for triangular. Next term is, whenever there will be the term impulse, then it represents a triangular function, triangular. And now it is said you have to find out the value of the actual value of rectangular part. So rectangular means even, therefore what we have to find out, I am writing that statement, it is given that rectangular part, so we can write, we have to find even part. Okay. Next term, rectangular part of impulse function. So rectangular part, even part of impulse is used for triangular. So even part of triangular function. Okay. Triangular function. Which kind of triangular function? Triangular function of half amplitude. Half is okay, but amplitude means width. So therefore, even part of rectangular function of half width is nothing but tau. Here the value of tau is given as 6 and width 12, and width is used for amplitude. Therefore, the value of amplitude of triangle is a is equals to 12. And one more information is given that this triangle is centered at t is equals to 3. Therefore, the center of this triangle, where this peak value of this triangle will be occurring, is given at t is equals to 3. So triangle is centered at 3. So we have to find out the even part, the value of even part of triangular function of this particular type, and where we have to find this value at t is equals to 6. So we must have to find out the value x of t, that is this triangular function, for which we have to calculate the even part. So if we see, it is x of t is a function that is a triangular function centered at t is equals to 3, having amplitude 12 and tau is equals to 6. So the value will be x of t is equals to, how you write a triangular function? A, therefore this 12 triangle of t minus center, so t minus 3, and divided by tau, and the value of tau is given as 6. So it is the triangular function. So how you can plot it? Let it is a function x of t. It is triangle x of t with respect to t. This triangle is centered at t is equals to 3. Let it is point t is equals to 3. It is centered at t is equals to 3, having half width 6. So half width is 6. Therefore, from t is equals to 3, half width is 6. Therefore, this point will be minus 3. So you have to draw a triangle for which the peak is occurring at t is equals to 3 and the half width of that triangle is 3. Therefore, it is 6. Therefore, this distance is 6 and this distance is also 6. Therefore, this point will be 9. It is not looking symmetrical, but you have to consider it. So it is x of t. Now we have to find the even part of this signal x of t at t is equals to 6. You know that if there is any signal which is neither even or nor odd, then you can find its odd equivalent or even equivalent, and you write even part of x of t is equals to x of t plus x of minus t divided by 2. So we have to find out the x of time reversal of x of t, that is x of minus t. It is x of t. So if you plot x of minus t here with respect to t, if we plot x of minus t. So this point, which is t is equals to plus 3, if we will take the time reversal or folding operation, then this point t is equals to minus 3 will come now at t is equals to plus 3 will come at t is equals to minus 3. Again, you have to draw a triangle of width 6, therefore these points will be, it is 3, it is minus 9, and the amplitudes in both the cases is 12. So amplitude in both the cases is 12. Now if you add these two signals, then this part from minus 9 to minus 3, only this signal is existing and the value of this signal is 0. So 0 plus anything will give you the same value. So if you plot the even part with respect to t, it is x of t. So if you are now plotting x of t plus x of minus t, you are just plotting x of t plus x of minus t. So now as you have told that this value is 0 plus anything will give you the same value. So from minus 9 to minus 3 there will be a straight line. Now if you see, we are now just drawing x of t plus x of minus t. Even part is x of t plus x of minus t divided by 2 also, but we are not considering 2. We are just adding these two values first, then we will divide all the values by 2. So now after t is equals to minus 3 and before t is equals to plus 3, in this duration, the slope of this signal is positive and the slope of this signal is equally negative. These two slopes are equal in magnitude, but it is increasing, therefore it is positive slope and it is having negative slope. In this duration, if positive and negative equivalent slope you will check, then the value will be 0. If the slope is 0, it means the value is constant in this duration. So you have plotted the value constant from minus 3 to plus 3. After plus 3, this signal ends up and now the value of this signal is 0. Therefore, the addition of these two signals will give you this straight line only. So the value will be like this. It is minus 3, this point is plus 3 and this point is 9. If you simply add up these two values, then what will be the value here? As this function is increasing from 0 to 12, so this value must be 12. But now if you find out the value of x of t plus x of minus t divided by 2, then this value will also get divided by 2 and it will be 6 only. So now if you have to find out the value of this even part of x of t at t is equals to 6, then we have to find out, here it is 3 and it is 9, in between there would be a value t is equals to 6. It is t is equals to 6. So we have to find out the value of this even part at this point t is equals to 6. If you see the slope of this straight line is reducing from 6 to 0 in times 6 seconds. So you can say that the slope of this line is minus 1, as it is decreasing value 6 in time interval 6. Therefore the slope of this straight line is minus 1. So if you move from t is equals to 3 to 6, so how much in time you have traveled? For 3 units. Therefore the value will also be decreased by 3 units. If you are at 6 here at t is equals to 3, then up to t is equals to 6, you will be decreasing the value by 3 units and therefore the remaining value at t is equals to 6 will be 3. So the correct option for question number 4, even part, the value at t is equals to 6 is, correct answer is 3. So now we will take question number 5. Thank you so much. Here I have already blank space. Now if we see question number 5, in question number 5 it is given, consider a discrete time signal x of n. We have given signal x of n which is equals to 3, then minus 2, 4, then minus 1, 5 and minus 2 with origin mentioned at n is equals to where the value is 4. So now if x of n is represented in terms of discrete ramp sequences only, then the slope of ramp occurring at n is equals to 3 is a. It is given that if we try to represent this, it is not x of t actually, it must be x of n. Yes, it is given as x of n. So x of n, if we try to represent this signal x of n in terms of ramp signals only, then the ramp which is occurring at n is equals to 3 will have a value of slope equals to, it is given as 3, given as a. Then we have to find out the value of 4a. So let us represent this signal in terms of ramp signals first. So if you take the values, let it is x of n. and if you have plotted the values at n is equals to 0, value is 4. Here it is n is equals to 0, value we have plotted 4. N equals to minus 1, the value is minus 2. So it is minus 2, it is 4. At n is equals to minus 2, the value is plus 3. So it is plus 3. At n is equals to, it is minus 2, it is minus 1, it is n is equals to 0. Now at n is equals to plus 1, the value is minus 1. So at n is equals to plus 1, we are taking the value minus 1. It is n is equals to plus 1 and the value is minus 1. At n is equals to 2, the value is 5. We are taking value 5 at n is equals to 2, and at n is equals to 3, the value is minus 2. It is at n is equals to 3, the value is minus 2. So we have seen in the lectures that if we have to represent, here the value is minus 3. So if we have to represent this sequence in terms of ramp sequences, then we have to start from n is equals to minus 3. It is n is equals to minus 3. Then you can just form a discrete ramp function in terms of dotted line, you can see here. And now you will have to mention slope of each dotted line, and then you will be able to find out the representation of this signal in terms of ramp signals. So if this point is n is equals to 3, then this point will be n is equals to 4. It is the axis of n. So now if you try to mention the slope of each signal, then here from 0 to 3, it is plus 3. So you are in one time you are gaining value 3, therefore you can say that the slope of this straight line is 3. Similarly, for this straight line, value is decreasing from 3 to minus 2, that is value is decreased by minus 5 in one time duration, therefore slope of this signal is minus 5. Here you can see from minus 2 we are going to plus 4, therefore the slope is difference between these two values, that is plus 6. Again here from plus 4 we are decreasing to minus 1, therefore the slope of this line is minus 5. Now slope for this line, we are going from minus 1 to 5, therefore slope for this line is plus 6. Again for this straight line, value is decreasing from 5 to minus 2, therefore the slope is minus 7. For this straight line, value is increasing from minus 2 to 0, therefore the value is plus 2. And now if you see here, you cannot stop to write the equation at n is equals to 3 only, because after n is equals to 4, this straight line is not going upward, it is just becoming constant. Therefore you will have to take a ramp function at n is equals to 4 also. So if you try to express this signal now in terms of ramp functions, then you can write x of n equals to the first ramp, that is occurring at n is equals to minus 3, will have the expression r of n plus 3, and the slope of this straight line is, previous slope is 0, after n is equals to minus 3, slope is 3, so 3 minus 0, the value of slope is 3. So for next ramp function which is occurring at n is equals to minus 2, you have written r of n plus 2. It is the expression, and now the slope, you will have to take the change in slope, therefore minus 5 and minus 3, the ramp slope is minus 8. Minus 5 minus 3, the slope of ramp that has occurred at n is equals to 2 is minus 8. Similarly, at n is equals to minus 1, after this minus 1, slope is plus 6, and before it is minus 5, therefore 6 minus of minus 5, you will have to write plus 11 r of n plus 1. Now at n is equals to 0, you can see after n is equals to 0, slope is minus 5 and before it is plus 6, therefore the change in slope is minus 5 minus 6, that is minus 11 r of n. Again at n is equals to 1, after n is equals to 1 plus 6, before minus 5, therefore 6 minus of minus 5, there will be plus 11 r of n minus 1, ramp which has occurred at n is equals to 1. Now at n is equals to 2, after 2 minus 7 minus 6, the change in slope is minus 7 minus 6, that is minus 13 r of n minus 2. Now at n is equals to 3, if you see the slope before n is equals to 3, it is minus 7 and after it is plus 2. So 2 minus of minus 7, that is plus 9 r of n minus 3. And now the ramp that has came at n is equals to 4, before the value of slope is 0 and after n is equals to 4, the slope is 0. Before n is equals to 4, slope is 2 and after it is 0, therefore we will have to write minus 2 r of n minus 4. So if you have to find out the value of slope of ramp that has occurred at n is equals to 3, then there is no need to express all the function. You just have to take the change in slope at n is equals to 3, and you can say that after n is equals to 3 slope is plus 2 and before n is equals to 3 slope is minus 7. So the ramp that has occurred at n is equals to 3 will have a slope 2 minus of minus 7, that is 9. So you have find out that slope of ramp occurring at n is equals to 3, that is given to be as a, it is equals to plus 9. Therefore the value of 4a is 4 into 9, that is equals to 36, and therefore the correct option for this signal for this question is option C. So for question number 5, option C is correct. So these were questions of 1 marks. Now we are moving to question of 2 marks, and the first question of 2 marks that we are having is, we have to evaluate the integral I, that is from integration from minus 6 to 68 del of minus 2t plus 26 triangle of t minus 30 upon 34 dt. So we have to evaluate the value of this integral. So if we see here, it is an impulse function, and it is multiplied with a triangular function. So if we say let this function x of t, so we are going to use shifting property of impulse function, that is x of t into del of t minus t naught dt integrated over this interval. So at first we will have to convert this function as we have discussed in the live lectures. Then whenever there will be a scaling in impulse function, then we must have to take this scaling factor out, then only we can apply shifting property. So let us see this first, as it is del of minus 2t plus 26. So we have seen that if we take this minus 2, whatever is multiplied with this t, we will have to take this coefficient out. Therefore it is minus 2 times del of t minus 13. It will be minus 2 times del of t minus 13. It can be written like this. Now you know that impulse function is an even function, so you can directly discard this negative sign. So you are now left with del of 2 times t minus 13. And now this scaling factor, you know that if there is del of alpha times t plus or minus beta, then you can take this scaling factor out, that is 1 upon mod of alpha times del of t plus or minus beta. All these things you have seen several times on GATE Academy Plus channel or in live lectures. So you must have comfortable with these terms. And now we can write this function as del of, finally we can write del of minus 2t plus 26. It can be written as, from here this minus sign is discarded, and now it will come as 1 upon mod of 2, that is 1 upon 2 only, del of t minus 13. So the value of this part, we can replace it as 1 by 2 times del of t minus 13. And as this 1 by 2 term is common, then therefore we can take this term out of this integral. Therefore now we are having integral I is equals to 1 by 2 times integration from minus 6 to 68, and it is del of t minus 13 times triangle of t minus 30 upon 34 dt. Now whenever such kind of integrals comes, the first thing that you have to notice is this impulse function occurring in between the given limits or not? So you can see here, this impulse will be occurring at t is equals to 13, which comes in between this integral. Therefore you can write it, if let this function we have mentioned at x of t, then the value of this integral will be, it is equals to, therefore we can write I is equals to 1 by 2 times value of this signal x of t at t is equals to 13, as this impulse function is occurring at 13 from the shifting property of impulse function. So now we have to find out the value of signal x of t at t is equals to 13. Now we just have to plot this signal triangle of t minus 30 upon 34. Let us see here, let it is time x is t. Here we have to plot x of t, that is triangle of t minus 30 upon 34. The first thing, we have to compare this with the standard representation A triangle of t minus center upon tau. So we have noticed that the center of this triangle will be at t is equals to 30. So center A of this triangle is at t is equals to 30, and the total half width of triangle is 34. It is tau. Tau is what? Half width. It means wherever it will be centered, it will be having this much width both the sides. So if we take 34 from t is equals to plus 30, then you will be at t is equals to minus 4. This point will be t is equals to minus 4, and if you move right towards right side by 34 units, then this point will be 64. So it is 64. Now you just have to plot a triangle which is centered at t is equals to 30 and having half width 34. And the amplitude of triangle is a triangle, you can say, therefore the value of a is 1. So the amplitude of triangle is 1. Now you have to find out the value of this signal x of t at t is equals to 13. So here it is any point, it is t is equals to minus 4. So here let it is a point t is equals to 13. So we have to find the value of this signal at t is equals to 30. Here this value is to be found out. Now if you see the slope of this ramp, slope of this straight line is gaining value from 0 to 1 in 34 times. Therefore slope of this function is 1 upon 34. Slope of this straight line is 1 upon 34. If you want to evaluate the value of this function x of t at t is equals to 13, then you will have to move from minus 4 to 13. How much distance is this? From minus 4 to 13, it is 17 distance. So if its slope is 1 by 34 means, if you will move 1 unit in time, then the value will be increasing by 1 by 34. If you are going to move 17 in time, then the value will be increasing by 17 into 1 by 34, that is equals to what? 1 by 2. Therefore, if you are 0 at 0 here, then at t is equals to 13, you will be gaining value 0.5. So this value is 0.5. So now, the final value for this given integral I is what? 1 by 2 times x of t at t is equals to 13. Substituting the value of t is equals to 13. Therefore, it is 1 by 2 into x of t is also 1 by 2 at t is equals to 13, that is 0.5. So the final answer for this question is 1 by 4 or 0.25. So it was a numerical answer type question. So the correct answer is 0.25. And again in this question you will not be having any kind of range, and it is coming perfect number, therefore there will not be any range given to you. Now in the next question, some of you may feel these type of questions lengthy or whatever, but when I was framing the question, I just want to draw some questions. Whenever I want to try to frame some question, then the first thing that comes in my mind, I take a picture of any question. In this question we will see that when I was trying to frame, I have taken just a picture of a signal, something like this. That what will be happening if we take any signal of this kind. So if you can see here, it is a simple signal. If I have written this signal, if in the question, if it is given in the form of such figures, then how easy it is to find out any value that you have asked. But now, if we simply give this picture not in the form of diagram but in the form of expressions, then why there is nothing that some of you should feel uneasy with these questions. You just have to plot the signal according to the given data, move stepwise, never think that any question is going to be tough. Yes, it may happen that some question can take some more time if you are not in practice. If you are in practice, then that time will be getting minimized with time. So if you see here, it is given that signal x of t is equals to summation from k is equals to 0 to 4. It is u of t minus 6k minus of u of t minus 6k minus 6. And with this, we have given another summation, that is summation from k is equals to 0 to 4 del of t minus 6k minus 8 into, it is plus del of t minus 6k minus 10. And now, with both of these summations, there is a term which is multiplied with it, that is minus 1 to the power k by 2 into cos of pi by 2k. So now if you see here, to form such signal, it was necessary that this summation should not give result for each values of k. Therefore, I have used the term cos of pi by 2k. Simply, whenever such questions comes in which there is a coefficient of particular signal, then you must have to check that coefficient first. Then what will happen with this coefficient? For which values of k this coefficient is going to give value, and what will be that value, and at which value of k this function is going to be 0. So you know that whenever k is any odd integer, then odd integer multiples of pi by 2 is always going to be 0. So for k is equals to 1 or k is equals to 3, this term will be 0, and therefore this overall x of t signal will become 0. So from this figure, you just have taken the values that here it is given summation from k is equals to 0 to 4, but you don't have to take all four values, you just have to take 0, 2 and 4. These three values you will have to take, and you can skip 1 and 3 because this signal will be 0. Now if this signal is non-zero, at k is equals to 1 and 3 signal will be 0, and at k is equals to 0, 2 and 4 this signal will be non-zero. So whenever this signal is non-zero, then what will be the value of this term? Minus 1 to the power k by 2. Minus 1 to the power k by 2, if you substitute k is equals to 0, then this term will be positive 0, and at 0 this term will give you plus 1. At k is equals to 2, this term will give you 1, that is an odd number. So you can see here the value of this term. It is for k is equals to 0, it will be plus 1. For k is equals to 2, it will be minus 1. Again for k is equals to 4, 4 by 2 is 2. Therefore this term will be having the value plus 1. So from this coefficient, you have seen that we just have to calculate the summation for k is equals to 0, 2 and 4, and for that values, for k is equals to 0 and 4, this coefficient will be plus 1, and for k is equals to 2, this coefficient will be minus 1. So now if you concentrate on these parts, what is it? If you substitute the values, x of t, now you can write x of t equals to, if you substitute 0, then this term will be u of t minus this term will be, as this k is 0, therefore this term and this 6k becomes 0, and you are having u of t minus 6. It is for k is equals to 0. Similarly, if you put k is equals to, and this coefficient, we have mentioned that the value for k is equals to 0, this coefficient will be plus 1. Therefore, we have taken coefficient of this term ut minus u of t minus 6 as plus 1. Or you can write it like this, it is this into plus 1. Okay. Now, for k is equals to 2, the coefficient is going to be minus 1. Therefore, we can take minus sign. And now if you put k is equals to 2 in these two terms, then at k is equals to 2, this term will become u of t minus 12. So I am writing here u of t minus 12, and minus this term will become u of t minus 18. Alright. Next, for k is equals to 4, you have to obtain the third value for k is equals to 4, and for k is equals to 4, again this coefficient is going to be plus 1. Therefore, for k is equals to 4, the values of these two terms, 6k, that is 24. Therefore, u of t minus 24, u of t minus 24 minus 6, that is, these terms will be u of t minus 24 minus of u of t minus 30. So you have three gate functions. If you see here, ut minus u of t minus 6, you have drawn several times these kind of function. This function will have value 1 in between 0 to 6. Similarly, this function will have value 1 or minus 1, you can say, if coefficient is minus 1, in between, from where, see here, we have just seen the sign of this minus 1 to the power k by 2, but the value of cos of pi by 2k at k is even number. So if k, you put k is equals to 0, then this term is also 1. So 1 into 1, the value will be, coefficient will be 1. It is correct. Alright. Now for k is equals to 2, this pi by 2k into 2, cos of pi by 2 into k is 2. You are taking the value of k is 2. Then this term is cos pi, and cos pi is minus 1. And the value of this term at k is equals to 2, it is also minus 1. So the product minus 1 into minus 1 will become what? Plus 1. So the overall coefficient for k is equals to 2 will also be what? Plus 1. For k is equals to 0, it will be 1. For k is equals to 2, it will be 1. If you check at k is equals to 4, you have mentioned the value of this term is plus 1. And at k is equals to 4, the value of this term, cos of pi by 2 into 4, that is cos of 2 pi, that is equals to 1. So the product is again 1 into 1, that is 1. Therefore, we have used this function minus 1 to the power k by 2. That's why we can have all gate functions positive. Therefore, the coefficients for these three, for k is equals to 0 or 2 or 4, the overall coefficient is always going to be plus 1. Therefore, all these signs are plus 1. Therefore, now you can see that we are having three gate functions. First gate function is occurring in between 0 and 6. second is occurring in between 12 and 18, and third one is occurring in between t is equals to 24 and 30. So we have three gate functions of width 6. Now if you see this term, again coefficient for these two signals are same, therefore for this also all the coefficients for k is equals to 0 or 2 or 4, the coefficient will be 1, therefore you just have to write out the values of these two parts. Therefore if you substitute the values, so first if you substitute k is equals to 0, then this term will be del of t minus 0 minus 8, that is del of t minus 8, and this term will become del of t minus 10. Therefore you are having two impulses, del of t minus 8 plus del of t minus 10. For k is equals to 2, it will be 12 minus 8, that is del of t minus 20, del of t minus 12 minus 8, that is 20, and plus del of t minus 22. If you put 2, then 12 and 10, it becomes 22. And for the third part, that is for k is equals to 4, del of 24 minus 8, that is del of t minus 32, and plus del of t minus 34. So now, as if you have to plot this signal, then you can plot it like this, that here it is a signal x of t which is having such values. For t we are writing, there is a gate function from 0 to 6 seconds, then there are impulses at 8 and 10, there are impulses at 8 and 10. In this question there is no need to plot this particular signal, but I am plotting it because I have started with the signal, therefore I am trying to plot the signal. So first gate function, then first these two impulses occurring at t is equals to 8 and 10, all have values plus 1. You can see all have values plus 1. You can say area of the impulses is plus 1. This is 1, all is 1. Now you are having another gate pulse from 12 to 18, so here it is from 12 to 18, this point is 12, it is 18. Again you are having two impulses at 20 and 22, it is 20 and 22, you are having two impulses. Again from 24 to 30, it is a step function, 24 to 30, and again you are having two impulses at 32 and 34. So you are already done with the signal, it is 32 and 34. Areas of all the impulses are 1 and amplitudes of these rectangular pulses are always 1. So it is your signal x of t. So now if you closely see what is being asked in the question, then it is asked that the signal y of t is defined in terms of x of t as y of t is integration from minus infinity to t x of tau d tau. That is, if you integrate this signal from minus infinity to t, then you will be having signal y of t. So you have to find out the steady state value of y of t. So the first method that you must opt to take this answer very easily, if you have to find out the steady state value. So whenever the steady state comes at t is equals to minus infinity or t is equals to plus infinity. So for t is equals to, if you substitute for steady state value of y of t, if you substitute t is equals to infinity, then what this integral becomes? Y of t at steady state. Steady state means at t is equals to infinity. Therefore, it will be integration from minus infinity to infinity x of tau d tau, which is nothing but area under function x of t. So if you count the total area, here there are three rectangles. So you will be having area of all these rectangles. All three rectangles have width 6 and height 1. All of these three rectangles are having width 6 and height 1. Therefore, this area is 6 into 1, that is 6. Area of this impulse is 1. This impulse is also having area 1. Again, this area is 6. It is 1. It is 1. Again, this area 6. Area 1 and area 1. So, if you count the total area, 3 times 6, that is 18, and 6 impulses having area 1. Therefore, 18 plus 6, the total area, you can easily evaluate it as 18 plus 6, that is equals to 24, and it is the correct option. But if you don't want to, and you can say if you haven't clicked that steady state value of this y of t will give simply the area, then you must have to integrate this function. And you know that integration of step function is ramp function, and integration of delta function, that is impulse function, is step function. If you have to integrate, you know that integration from minus infinity to t del of tau d tau, it is what? It is equals to ut. or if you substitute t from t minus t naught, if you replace, therefore if there is integration from del of t minus 2 integrated from minus infinity to t, so it will give you del of u of t minus 2. So if you plot the integration directly of the signal, see, we are not concerned with the solution. We are trying then when in 2024 you will be appearing for the test, then there must not be any point from where they can ask question that you are not familiar with. So what are the other methods if you want to find out the value of integration of this signal from minus infinity to t? So from the given result you can write integration from minus infinity to t x of tau d tau. It is equals to integration of ut will give you r of t minus integration of this u of t minus 6 will give you r of t minus 6. Next part, this if you integrate this value del of t minus 8, integration will be u of t minus 8 then plus u of t minus 10. Similarly, if you integrate step next, then you will be having plus r of t minus 12 and minus r of t minus 18. Then you will be having plus u of t minus 20 and plus u of t minus 22. Then next term will be integration of step, that is r of t minus 24 minus r of t minus 30, and next for impulses integration will be u of t minus 32 and plus u of t minus 34. So if you plot this signal, can you plot this signal which is having some ramp functions and some step function? Let us try to plot this signal. If you try to plot we are trying to plot signal y of t here. These are the points. The first ramp function is starting, the signal is starting with a ramp having slope 1, and this ramp is going to move alone till t is equals to 6. You can say that this ramp will be occurring at t is equals to 6. So in between t is equals to 0 and 6, you have plotted in between t is equals to 0 and 6 seconds a ramp function of slope 1. Therefore, you will be reaching a value of 6. In time 6 duration, if the slope is 1, then the value you will gain is 6. Now at t is equals to 6, what happened? There comes a ramp having slope minus 1. Therefore, the net slope after this point t is equals to 6, it will be constant. Slope will be 0, therefore the signal will be constant. After t is equals to 6, what is going to come? At t is equals to 8, you are going to have a step change of 1 unit. So here now you are at 6, and at t is equals to 8, let us consider this point. At t is equals to 8 seconds, there is a step change of 1 unit. So from 6, you will be moving to 7. Next is what? Again you are having a step change at t is equals to 10 seconds. So the value is constant from 8 to 10. 8 to 10, the value is 7, but at t is equals to 10, there occurs another step of amplitude 1. Therefore, this point will be, this value will be 8. After t is equals to 10 seconds, the next ramp is going to come at t is equals to 12. So at t is equals to 12. Now if we see, let it is the point t is equals to 12 seconds. So after this t is equals to 12, slope is 0, but ramp is occurring having slope 1. Therefore, after t is equals to 12 seconds, there will be a ramp of slope 1. If the ramp is having slope 1, it means this ramp is going to move along till t is equals to 18. So at t is equals to 18, this ramp will reach up to, if the slope of this ramp is 1 and this ramp is moved for t is equals to 6 seconds, so this value will also increase by 6, and therefore this value, it will be 8 plus 6, therefore this value is 14. This value is 14. I'm sure you will be familiar with this due to previous lectures only. So now you can take the value similar. Now after t is equals to 18 seconds, there comes a ramp with slope minus 1. Therefore, the net slope will be, here the slope is plus 1, but at t is equals to 18, ramp occurs with slope minus 1. Therefore, after t is equals to 18, slope will again become 0 and the function will become constant at 18. Now at t is equals to 20 and 22, there are 2 step changes. Therefore, we are increasing these values. At t is equals to 20, we have increased by 1 unit, and after t is equals to 22, let it is point, t is equals to 22, then we have increased this value by 1. So we are now at 15 and this is 16. So now we are at 16 and this point is t is equals to 22. After 22, at t is equals to 24, there will be a ramp occurring and it will move up to t is equals to 30. So at point, let it is a point, t is equals to 24. So at t is equals to 24, a ramp occurred with slope 1 and it will move till t is equals to 30 seconds. So the value in 6 time duration, the value will again increase by 6. Therefore, you will be reaching to 16 plus 6, that is 22. And now, after t is equals to 30 seconds, there comes a ramp with slope -1. Therefore, after t is equals to 30 seconds, the slope will be again constant. Slope will be 0, so the signal will be constant. And after 30, there will be two step changes at 32 and 34. Therefore, you will be reaching up to this value. So we are now done with the signal. So we can rub it. Now, finally, after these are instants, this is 32 and it is 34. So now for any value of time greater than t is equals to 34, this signal is now going to be constant at this value. And what is that value? This value is 22. This is one step change. Therefore, this value is 23. And after one step change, this value would be 24. So now if you have to find out the steady state value of the signal x of t, then what is the steady state value? This signal is becoming constant at for 24 after t is equals to 34. Therefore, you can say that steady state value of the signal yt is 24. So it is the lengthy process, but you must have idea of this function, this process also, because it is the basic process. It is nothing, and I have given you one question on this type of activity also. So the answer for this question number 7 is 24. So answer for question number 7 is 24. Now, if we move on to the next question, that is question number 8. This question, you don't have to think that this question was too lengthy. I have just taken time to detail discussion for give you the detailed discussion. Otherwise, this question, if you have plotted this signal by these two signals, you have plotted the signal and find out the area, that will be the answer, that is 24. So now the next question is, consider a discrete time signal given as, it is question number 8. And yes, there is a mistake in this question. When I have given you, there is a mistake, and Rishabh Jain was the first who pointed it out. So thank you, Rishabh. And this question will definitely go to MTA. So you don't have to take any kind of tension for this. But the concept that we want to discuss, that is important. And if any of you having problem in discrete time signals, then just see it. We have given, consider a discrete time signal x of n. We have given a signal x of n, that is 2 minus summation from k is equals to 5 to infinity. Yes, it is 5 to infinity. It is 4 times delta of 2n minus 4 minus 2k. 2n minus 4 minus 2k. Another signal y of n is related. Y of n is related to x of n as 1 minus x of n. And it is also given that this signal y of n can be represented as, yn is equals to u of an plus b minus of u of n minus c, which is not correct. We will see what fault is in this given expression. Then we have to find the values of a plus b plus c. We have to find out the value of a plus b plus c. We are not changing the question. Whenever we will find the correct expression, then we will substitute the values of a, b and c, and we will find the answer. So let us start to see here this term del of 2n minus 4 minus 2k. Actually, we have not studied discrete time impulse function in live sessions, but you have studied this type of questions in GATE Academy Plus lectures, so we can include it. Therefore, it is del of, if you take 2 common, then it will be n minus 2 minus k. And you know from the property of impulse function that if del of alpha n if there is del of alpha n, then it is equals to del of n only. As you, how it comes, you can see here. If you define del of n, then you write del of n is 1 if n is equals to 0, and it is 0 if n is not equals to 0. It is not like continuous time impulse function that is value infinity. The value is well defined at n is equals to 0 and it is equals to 1. So if you have to find the value of alpha n, so by the operations on signals, what we have seen is, if we have to replace this n by alpha n in LHS, then we must have to replace n by alpha n on LHS also, RHS also. So it will be 1 when alpha n is 0 or it is similar to n is equals to 0. Therefore, x del of n and del of alpha n is same. Therefore, there is no effect of scaling on discrete time signals. Also, if you say that del of alpha n is nothing but equals to del of n, so if you replace n by n plus or minus n naught, so del of alpha times n plus or minus n naught will be equal to del of n plus or minus n naught. So if you have taken a scaling factor common, then you can discard this scaling factor and this will be equal to del of n minus 2 minus k. This impulse function is equivalent to del of n minus 2 minus k. So if you substitute the value, then x of n is going to be 2 minus, we can take this 4 common outside, so there it is 4 times summation from k is equals to 5 to infinity del of n minus 2 minus k. If we substitute k from 5 to infinity at k is equals to 5, this function will become n minus 7, that is the impulse existing at n is equals to 7. For 6, it will be del of n minus 8, that is impulse at n is equals to 8, and so on. It means it is the series of impulses that are occurring from 5. If you substitute 5, then it is n minus 7, that is, it is the series of impulses that is starting from n is equals to 7 and will occur up to infinity, having values 4. So what this term will give you, if you plot a discrete time 2, that is constant in discrete time, then it is 2, it is having value 2 for each values of n. It is having value 2 for each value of n. All the values are 2. It is discrete time constant signal 2. Now you have to subtract the signal x of n. Here it is this function del of n minus 2 minus k. We have seen that this function will be starting from n is equals to 7 and all the samples will have values 4 and this function will exist up to infinity. So if you subtract these two functions, so what are you going to obtain? You will be having these values, let it is 1, 2, 3, 4, 5, 6 and let it is 7, 8, 9 and so on. Let it is 7, 8, 9 and so on. So if you will be subtracting this value which is occurring from n is equals to 7. So before n is equals to 7, this signal is 0. So 2 minus 0, the value of signal x of n. If you plot difference of this signal, if you plot difference of these two signals with respect to n, we are now plotting x of n, that is 2 minus this signal. So this x of n will be having values 2 up to, from minus infinity, this value is 2 up to, here it is at n is equals to 7, the value will be changed because this value is 2 and at n is equals to 7, another impulse occurred that is having value 4. So before n is equals to 7, all the values will be 2 minus 0 will be, that will be 2. Therefore, from minus infinity to 6, you will be having for 1, 2, 3, 4, 5 and 6. For n is equals to minus infinity to 6, you will be having value of x of n as 2. And now, it is the point n is equals to 6. And after n is equals to 6, that is from n is equals to 7 to infinity, the value will be 2 minus 4, that is equals to 2 minus 4, that is equals to minus 2. So the value after n is equals to 6, that is from n is equals to 7 to infinity, from n is equals to 7 to infinity, the value is minus 2. So it is the signal. Now, if you try to find out signal y of n, then this y of n signal is given as what? Y of n is 1 minus of this signal x of n. If you substitute this signal from constant 1. Constant 1 is a signal that is having value 1 throughout for n is equals to minus infinity to plus infinity. So if you subtract x of n, this signal, from 1, then 1 minus 2, the value will be minus 1 from minus infinity to 6. So the value is going to be, for this subtraction, the value, all the values will be minus 1, because we are subtracting this 2 value from 1, constant 1, and we are subtracting 2. So therefore 1 minus 2, the value is minus 1. So the value is minus 1 from minus infinity to 6. Minus infinity to 6, the value is 1 minus 2, that is all these values are minus 1. Here we are plotting the signal y of n, and after n is equals to 6, that is from n is equals to 7 to infinity, what will be the value? We are subtracting this signal from 1. So 1 minus of minus 2, the value will be plus 3. Therefore, after n is equals to 6, it is the point n is equals to 6, and from point n is equals to 7 to infinity, you will be having the value 1 plus 2, that is 3. It will be up to infinity. So these values are 3 with respect to n. So now if you have to express this signal y of n in terms of step functions, step sequences, then what will be your expression? Y of n, you can write, let you are considering any step function that is existing from minus infinity to plus 6. So what will be the expression? U of minus n plus 6. We have seen that if you write u of minus n plus 6, then it means this signal is starting from minus infinity and will exist up to t n is equals to 6. But this, if you write nothing before this step, then it means the value of this step sequence are all plus 1. But here we are having the value from minus infinity to plus 6 as value is minus 1. Therefore, we will have to put a minus sign before this term. Therefore, y of n can be represented for these values from minus infinity to 6. We have written the expression as u of minus n plus 6. And for 7 to infinity, if there is a function that is existing from 7 to infinity having all of its values to be 3, so this signal, this part of the signal can be represented as 3 times u of n minus 7. Is it clear? Can you write it? From the signal that is existing from 3 to 7 to infinity having value 3, so it can be written as 3 times u of n minus 7. So now if you have to compare, now I am modifying the question. If it is given in the question that y of n is given as u of minus times u of an plus b and plus 3 times u of n minus c, then you have to find out the values of signal constant a plus b plus c. So now if you take here, if we have modified the question as y of n is equals to minus of u of an plus b and plus 3 times u of n minus c. So if you compare these two equations, then you can get a is equals to minus 1, b is equals to 6 and c is equals to 7. A is equals to minus 1, b is equals to 6 and c is equals to 7. So the value that is asked, a plus b plus c, that is minus 1 plus 6 plus 7, that is 13 minus 1, that is equals to 12. And now you can see one of the option is given to be 12 and it is option B. So the option B that is having value 12 is correct. If we take yn is equals to this kind of value, then only you can find this result. Therefore this question goes to MTA. This question number 8 will be marks to all. Either you have attempted it or not, you will be having marks for this question. So the concepts behind the questions are really important. Therefore, you must watch these videos and you must participate in the test first. Otherwise, you will not having an interest on these solutions because you don't have curiosity that why I have did wrong. I have committed a mistake on that question. So now we are moving to question number 9. And in this question number 9, it is given that area under the signal, we have to find out the area under the signal, that is x of t is equals to r of t plus 3 times u of t minus 1 plus 5 times r of t minus 1 minus 12 times r of t minus 2 and plus 12 times r of t minus 3 minus 6 times r of t minus 4 minus 10 times u of t minus 5. It is the signal for which we have to find out the area. So this type of question we have just tried in question number 8, I think. So now 7. So now you can plot this signal and we have to find the area. So now to start with, here you can see that this ramp function will start from t is equals to 0. It will be starting from 1. This signal will also occur at t is equals to 1. This signal will be occurring at 2. It will be occurring at 3. This will be occurring at 4, and this will be occurring at 5. So just try to plot this signal. If you try to plot this signal with respect to t, first signal is ramp function, and that is going to move from 0 to 1 seconds with slope 1. Therefore, if you plot a signal from 0 to 1 seconds with slope 1, therefore this value is again 1. Then a step change of 3 is occurring at t is equals to 1. Therefore, suddenly you have made a step change of step 1. So this value will be 1 plus 1, that is, sorry, it is step change of 3 units. Therefore, 1 plus 3, this value would be 4. Now at t is equals to 1 only, a ramp is also occurring having slope 5. So the net slope after this ramp will be plus 1 and plus 5. The net slope will be plus 6, and this plus 6 will be moving from t is equals to 1 to t is equals to 2. Therefore, from t is equals to 1 to t is equals to 2, you have plotted a signal having slope 2. Slope of this signal is 2. For slope of this ramp is 1. The slope of this ramp is 1, but for this signal slope is not, it is not 2, it is 1 plus 5, that is 6. Slope of this signal is 1 plus 5, equivalent slope is 6. So if you move with slope 6 for time 1 unit, then you will be gaining value by 6 units. Therefore, if you are at 4, then at this point you will be at 10. After t is equals to 2, the ramp that has occurred is having a slope minus 12. So slope of this signal is plus 6, and the ramp that has occurred at this point is having a slope minus 12. So the net slope after this point plus 6 minus 12, you will be having a slope of minus 6. So if you move one time unit, here you have to move from t is equals to 2 to t is equals to 3. That is, a ramp will be moving from t is equals to 2 to 3 having a slope of minus 6. Therefore, if you have in one time you have gained 6, then in one time now you are reducing 6, and this value will be 4. It is the point t is equals to 3 seconds. After t is equals to 3 seconds, one ramp has occurred having slope plus 12. The value of slope for this line is minus 6. The ramp that is occurring at t is equals to 3 seconds is having a slope plus 12. Therefore, the net slope after this point will be minus 6 plus 12, that is plus 6. Therefore, we are again reaching to this value after time 1 second. It is t is equals to 4 seconds. The slope of this ramp is plus 6. Therefore, in time 1 duration, you have gained value 6 and you have reached up to 10, moving from 4. Now, after t is equals to 4 seconds, what happened? Another ramp is occurring having slope minus 6. So, before slope is plus 6 and a ramp occurred at this point having slope minus 6, therefore, after this point, the signal will get constant because the value of its slope is 0. Until where? Up to t is equals to 5 seconds. Let it is t is equals to 5 seconds. Then at t is equals to 5 seconds, a step is coming having the change of minus 10. So if now you are at 10, then after t is equals to 5 seconds, the value will be decreased by 10, and therefore the value will become 0, and the now signal is constant at this point. So it is the function for which we have to evaluate the value of area. It is our signal x of t. So if you have to find the area of this signal, then simply you can divide this function in terms of rectangular and triangular functions. If you take, see here, if you take this one rectangle, if you take this rectangle, now no need for these dotted lines. So first, if you take this rectangle, let it is area 1, or you take this first this triangle, let it is area 1, this rectangle you can say area 2. For this triangle, if you mention area 3, for this triangle, if you mention for this triangle, let it is area 4, and for this rectangle again, let it is area 5. So you have to find out all 5 areas, and the sum of all these areas will give you total area under the function x of t. So A1 is what? A1 equals to 1 by 2 into width of the triangle is 1 and height is 1. Therefore, it is 0.5. What is the value of A2? Width is from 1 to 5, that is width is 4 and height is 4. Therefore, it is equals to 16. What is the area A3? 1 by 2, width is from 1 to 3, that is width is 2 and height is 4 to 10, that is 6. 1 by 2, width is 2 and height is 6. So it is 6. Similarly, area A4 is 1 by 2, width is 3 to 4, that is 1, height is 4 to 10, that is 6. So it will be 3. And area for A5, width is 1 and height is 6. So it is equals to 6. So the total area A is equals to A1, that is 0.5, plus A2, that is 16, plus A3, that is 6, plus A4, that is 3, and plus A5, that is 6. Therefore it is 16 plus 6, 22 plus 3, that is 25, plus 6, that is 31.5. So the total area is 31.5 square units, and it is the correct option for question number 9. So the correct option for question number 9 is 31.5. Please rub those portions. Now, if we see question number 10. So in question number 10, it is given that x of t is a signal having value sinc of t by 3 and y of t is a signal that is having value sampling of pi t by 4, and z of t is another signal which is given to you as 4 triangle of t minus 5 by 4 into rectangle of t minus 5 by 4. So now it is given that let t is equals to t1, let t is equals to t1 is the first positive value of t at which x of t and y of t simultaneously becomes 0, then the value of z of t at t is equals to t1 is. See here, you can see that these two functions are sinc and sampling functions, and these functions will have zero crossing frequencies, zero crossing intervals of times at which these functions become 0. If you see sampling function or sinc function first, we have seen that, let us represent, if we write sinc of t, then it is equals to, we know that, sin pi t upon pi t. Therefore, we have mentioned that whenever this numerator will become 0, overall function sinc of t will cross the 0 value. Therefore, we have taken the value of t as any integer value, the function will be 0. So, if you draw sinc of t, then you know that the sinc of t function is crossing 0 points at integer multiples, that is 1, 2, 3, 4 and so on. These values are minus 1, minus 2 and so on. So sinc function will have 0 crossing points of t as t is equals to 1, 2, 3, 4 and so on. Now if you see signal x of t, then it is sinc of t by 3. What is the effect of scaling? Here if you are scaling alpha is 1 by 3 in this case, then you have to divide all these 0 crossing points by 1 by 3. Therefore, these points will get multiplied by 3, and therefore if you plot x of t, your signal x of t, then this signal x of t will have now the points 3, 6, 9, 12 and so on. These will be the 0 crossing points for signal x of t. Obviously the amplitude, that is value at t is equals to 0 is 1, as it is nothing before this sinc function. Therefore, it is the values of sinc of t where this function is getting 0 at t is equals to 3, 6, 9, 12 and so on for values of t. Similarly, if you see now, you know that sampling of t is related to sinc of t as, or you can write sinc of t, relation between sinc function and sampling function. You have seen that sinc of t is equals to sampling of pi t. You know that as sampling function is given as sampling of t, you write it sin t upon t. Therefore, if you replace both of these t by pi t, then you will be having sinc function only. Therefore, sampling of pi t can be written as sinc of t. Similarly, if you see here y of t, then y of t is sampling of pi t by 4. It means if sampling of pi t is sinc of t, then sampling of pi t by 4. What you are taking, if you are taking t as t by 4 and in right hand side, then you must have to take here also sinc of t by 4. Therefore, it means this signal y of t is nothing but sinc of t by 4, as this signal x of t is sinc of t by 3 having 0 crossing points at 3, 6, 9, 12 and so on, that is integer multiples of 3. Similarly, the given signal y of t, if you plot y of t here, then this signal is having, this signal y of t is equals to sinc of t by 4. Therefore, this signal will be having points crossing the zeros at 4, 8, 12, 16 and so on. So if you see the first positive value of t for which both of these signals are simultaneously getting 0, it means which is the first instant of time which is 0 crossing point for both of this signal, then you will have to take LCM of these values. Therefore, you will be getting the value 12. The first value is 4, 8, 12. At third instant, this signal is 0 at t is equals to 12, and for this also 12 is the fourth 0 crossing point for sinc of t by 3. Therefore, you can write that the value of t that is given to be as t1, then you have taken the value of t1 is equals to 12 seconds. So now you have to find out the value of this signal z of t at t is equals to 12 seconds. Now the question is really easy, as whenever you as you see here, it is triangle of t minus 5 by 4. We have not space here. So now we have seen that we have to evaluate the value of the signal z of t, which is given to us as z of t is 4 triangle of t minus 5 by 4 into rectangle of t minus 5 by 4. So if you have to find out the value of this signal at t is equals to 12. First, if you see, there is now no need to calculate the value, as we can see here that these two functions are centered at t is equals to 5 and having width, total width 4 and half width 4. So these value will not reach up to 12, and at t is equals to 12 this function will not be existing. Therefore, the value of z of t at t is equals to 12 is 0. So we have already got our answer, that is value for this question z of t at t is equals to 12, it is equals to 0. But if you have to find out the value of this signal, let us say at t is equals to 3. If we have to find out the value at t is equals to 3 or t is equals to 6, we say if we have to find the value at t is equals to 6. So how have you plotted this signal? It is triangle of t minus 5 by 4. Individually plot the signals and then take their multiplication. So this signal is centered at t is equals to 5, having half width 4. Half width 4, therefore we have drawn a signal having half width 4, therefore this point will be 1 and this point will be 9. And the amplitude of this triangle is given to be 4. It is, your signal say it is z1 of t and let it is z2 of t. So it is first signal which is centered at 5 having half width 4. This next function is with respect to t only. If you plot, let it is z1 of t and you have to plot z2 of t, that is equals to rectangle of t minus 5 by, or you don't have to write it here. So we have to plot a rectangle having amplitude 1 centered at 5 and total width 4. Now this rectangle is also centered at 5 only, but the total width is 4. It means it will be from 3 to 7. It is a rectangle from this point is 3 to 7, so that the total width is 4 and the amplitude for this signal is 1. Therefore, if you multiply these two signals, so after you can say that from t is equals to 1 seconds to 3 seconds, this signal is having any value, but as the signal is 0, so the product is going to be 0. Similarly, after t is equals to 7 seconds also, after t is equals to 7 seconds, the product will be 0 only. Therefore, if you draw the product, that is z of t, then you will get a function like this. This signal will be existing from t is equals to 3 to 7 and the values, as this value is 1, therefore the product will have the value same of the signal. And this signal, if it is moving from 0 to 4 in 4 duration, then it means slope of the signal is 1. As slope is 1 because if we travel 4 units in time, then 4 value is gaining, therefore for slope is 1 and for this line slope is minus 1. So if you have to take the value of this signal at t is equals to 3. So you have moved 1 to 3, that is for t is equals to 2 seconds, therefore the value of this signal will also become 2. Similarly, if you are at 4 and this line is decreasing with a slope minus 1, then at t is equals to 4 seconds, after this point, from, if we have to take this value is 7, so if you have to take this value at t is equals to 5, the value is at 4. So if we move 2 units, then the value will decrease by 2 and again the value will be 2. So these values are, this value is 2 and this value is 4. It is your signal z of t with respect to t. So you can see that the value of z of t at t is equals to 12 is 0. But at t is equals to, if we have to find out the value of this signal at t is equals to 4 seconds, we have to find out the value of z of t at t is equals to 4 seconds. Then you can see that the slope of this line is 1. The value at t is equals to 3 is 2. If you move 1 unit, then the value will also gain 1. Therefore, this value will be 3. Similarly, you can find for any other values of t. Therefore, for this question, question number 10, the correct option is 0. Z of t at t is equals to 2 is 12 is 0. So it is correct option for question number 10. Next, signal x of n. Now, this is the question based on even and odd signals. Signal xn and its odd part. So before starting this question, question number 11, we have, as we have written for continuous time signal some questions before, that x even of t can be written as x of t plus x of minus t divided by 2, and x odd of t is equals to x of t minus of x of minus t divided by 2. So how you get these values, or what will happen if you add up these two values? If you add up these two values, then you are left with x of t. So in every case at any instant of time, either it is continuous or it is discrete, the relation that must be followed is any signal x of n can be represented in terms of its even part and its odd part. In particular, if x of n is even, then this odd part will become 0. If x of n is an odd signal, then even part of that signal will definitely be 0. But this definition, this result is valid for each and every instant of time. Either we see for n greater than 0, or we see for n less than 0, or we see at n is equals to 0. These values will always get satisfied. So we have given that x of n, I can write in the form of sequence representation. We have given x of n only for n greater than 0, and these values are, we don't have any idea that how the values of signal x of n are going to be before n is equals to 0, but at n is equals to 0 the value is 6. We know that at n is equals to 1 the value is 4, and at n is equals to 2 the value is 2. It is given for signal x of n. Also, the odd part of this signal x odd of n is also given x odd of n. It is also given that the values of x odd of n, but it is given only for n less than 0. So the values for this odd of n signal is, obviously if the signal is odd or odd part, then its value must be 0 at n is equals to 0, and the values are 2, then it is 4 and 6. So these are the values of x odd of n. Now, if you write x of n, if you have said that any signal x of n can be written in terms of even and odd parts, then these even and odd parts must be even and odd functions. These parts are, therefore you are giving it name odd part or even part, definitely they will be, if there is even part of any function, then in itself it will be an even function, and x odd of n is always going to be an odd function. And from the property of even and odd function, you know that if signal is even, then x of minus n is nothing but x of n, and if signal is odd, then x of minus n is minus of x of n. Right? So now, if you see, if you have given an odd signal and for n less than 0 only, it means that for n greater than 0, there must be their negative values what are given before n is equals to 0. Therefore, you can evaluate this x odd of n completely with this information that if this signal is 2 at n is equals to minus 1, then definitely this signal will become minus 2, it will be minus 2 for n is equals to plus 1. Similarly, if it is 4 at n is equals to minus 2, then n is equals to plus 2, the value of signal will be minus 4. And at n is equals to minus 3, it is 6, therefore this value will be minus 6. So now you have x odd of n for all values. Now, it is asked the sum of values of x of n, we have to check out. So if it is odd function, x odd of t, odd equivalent of the signal, then using this relation, if we want to find out this even part, then we can find out the even part of x of n. What will be the even part? From this equation only, x even of n can be written as x of n minus of x odd of n. If you have to find out this even part for n greater than 0 only, then also you can use this result. If you have to find x even of n for n less than 0 only, then also you can use this result. So if we have x of n for n greater than 0 and we also have x odd of n for n greater than 0, then we can find out x even of n, even part of signal x of n for n greater than 0. What will be the value? X of n minus of x odd of n. Therefore, if you substitute these values, then 6 minus 0, the value of x even of n at n is equals to 0 will 6. 4 minus of minus 2, the value will be 6. 2 minus of minus 4, the value will be 6. And now, if it is not having any value, then it means it is 0. Therefore, 0 minus of minus 6, the value will again be 6. So now, what you have obtained is even part of signal x of n. And if it is an even function, then it must follow this equation that x of minus n equals to x of n. Therefore, if this signal is having values 6, 6 and 6 after the origin, then it must have the value 6, 6 and 6 before the origin as well. Therefore, we can write these values as 6, 6 and 6. Now, we have complete odd part and complete even part. And this relation is always valid. Therefore, we can obtain this signal x of n completely. If we don't have this value of signal x of n for n less than 0, then we can simply add even part and odd part of the signal and we can have the value x of n here. So the value 6 plus 2, the value of x of n will be 8 at n is equals to minus 1. 6 plus 4, that will be 10 at n is equals to minus 2. And 6 plus 6, that is 12, it will be the value of signal at n is equals to minus 3. So now we have obtained complete x of n signal. Therefore, we can obtain the value that is being asked, that is x of minus 4 plus x of minus 3 and plus x of minus 2. So you can see it is n is equals to 0, minus 1, minus 2, minus 3. Signal is existing only after n is equals to minus 3, therefore the value of x of minus 4 is 0. It is 0, x of minus 3, the value is 12 and plus x of minus 2, the value is 10. So the value 12 plus 10, the value is going to be 22, and if we see the options, then option C is correct for question 11. So now we have got the answer, the sum of sequence x of n, x of 3 and x of minus 4 plus x of minus 2 is equals to 22. Now if we see question number 12, in this question we have given that signal x of n is r times n plus 8 minus of r times n plus 7 is multiplied to a sequence that is u of n minus 8 minus of u of n minus 9. This is our signal x of n. Then the value of summation, we have to find out the value of summation s, which is given to be summation from n is equals to minus 20 to plus 20. It is n square plus n divided by 2 into x of 2n. So now, if you see here, this question is just a one-liner. You know that if you write u of n, then it is equals to r of n plus 1 minus of r of n. And you already seen that if you have to find any unit step function here, if you have to find u of n plus 8, then similarly, simply you have to take this function here, r of n plus 8, and this term will be one more, that is r of n plus 9. So this result will give you u of n plus 8 only. Now you see here, r of n plus 8 minus of r of n plus 7. Therefore, this term is n plus 7. So you can write u of n plus 7. It will be what? R of n plus 8 minus of r of n minus, it is plus 7. Plus 7. Signs will be same in both the cases. So n plus 7, n plus 8, if you have to find the difference of these two consecutive ramps, then n plus 8 minus r of n plus 7 will give you u of n plus 7. So now this part of signal is known to us as u of n plus 7, right? So this function u of n plus 7, how does it look like? It is the signal which will start from n is equals to minus 7 and will have value 1 from minus 7 to infinity. Now, if you see this question, this part, u of n minus 8 minus u of n minus 9. If you plot u of n minus 8, then this signal will be starting from n is equals to 8, all values will be 1. This is your signal u of n minus 8. Similarly, if you draw with respect to n, if you draw u of n minus 9, then the signal will start from n is equals to 9 and again it will be existing from 9 to infinity. This is signal u of n minus 9. If you subtract these two signals, then after n is equals to 9 or from n is equals to 9, you can say the difference will be 1 minus 1 0. The only instant of time where this difference is non-zero is n is equals to 8, as at n is equals to 8 the value of this signal is 1 but this signal is having value 0. Therefore 1 minus 0, the result of this difference u of n minus 8 minus u of n minus 9, you are getting this as a single impulse at n is equals to 8. Therefore, if there is an impulse in discrete time case, if there is an impulse occurring at n is equals to 8 having value 1, then you can write it like del of n minus 8. It means this part is also known to us now. It is del of n minus 8. So now this product, if you see x of n, therefore now you can write that this signal x of n is equals to u of n plus 7 into del of n minus 8. So as you write the properties in case of continuous time impulse function, similarly you have the property that x of n into del of n minus n naught, it is equals to what? X of n into del of n minus n naught, it is equals to this impulse will be as it is n minus n naught, and now the value of this impulse will get decided by the value of this signal x of n where this impulse is existing, that is x of n naught. So if we have to take a product of any signal with shifted impulse, then first we have to see where this impulse is existing and we have to put this value of n in the signal x of n. So if you see here, this let it is x1 of n, let it is any signal x1 of n. So x1 of n into del of n minus 8 is equals to this impulse will be as it is del of n minus 8, and you will have to find value of x1 of n at n is equals to 8. So you will have to find value of x1 of n at n is equals to 8, that is mentioned to be as x1 of 8 into del of n minus 8. It is our signal x of n. Now if you see x1 of n, this signal is u of n plus 7. We have already discussed that this signal u of n minus 7 will be existing from n plus 7 will be existing from minus 7 to infinity. We have seen that this signal u of n plus 7, it will be having value 1 from minus 7 to plus infinity. Therefore, if we have to find the value of this signal at n is equals to 8, then the value, all values are 1 that have been started from minus 7, and at n is equals to 8, if you see, the value will be 1 only at n is equals to 8 also. Therefore, this value x1 of 8 is 1. Therefore, this total product x of n is nothing but 1 into del of n minus 8, that is, this product is equals to simply del of n minus 8. So now x of n is equals to del of n minus 8. In this summation, what we have given n square plus n by 2 into x of 2n. So at first, we must have to see what this signal x of 2n representing. Therefore, if x of n is equals to del of n minus 8, then x of 2n equals to del of 2n minus 8. It is x of 2n. We have just replaced n by 2 on both the sides. Therefore, it is del of 2n minus 8. And from the property of impulse function, scaling property, this can also be written as del of, if we take 2 common, then it is n minus 4. And this scaling factor can simply be discarded. Therefore, this signal x of 2n is going to be del of n minus 4. Now, if we evaluate the summation, S is given to be summation from n is equals to minus 20 to plus 20, n square plus n upon 2 into x of 2n, and x of 2n is del of n minus 4. So now from the shifting property of impulse function in case of discrete time, you know that if there is any function x of n into del of n minus n naught, if you don't take the summation, then this product will be an impulse, but if you take the summation, then the area under the impulse, or you can say its value, it is from any particular limit which includes this value n naught. It may be minus infinity to plus infinity, it may be n naught just before n naught and just after n naught. If you are taking the summation, then also this value will become the same result, and it is equals to x of n naught. You know that, find out the value of n by substituting this value equals to 0, and then substitute that n value in x of n. Therefore, this summation will have result x of n naught. Now, if you see here, let us say this function is to be x of n. Then this summation, at first you have seen that this impulse is occurring at n is equals to 4, and this 4 is in between these two limits. Therefore, this summation will have a value of this signal x of n, that is n square plus n upon 2, value of this signal at n is equals to what? Where this n minus 4 becomes 0. Therefore, we will have to put n is equals to 4 here, and the value becomes 16 plus 4, that is 20, divided by 2, that is equals to 10. So the correct option for question number 12 is 10. For question number 12, correct answer is 10. Now if you see the next question, question number 13. Next is question number 13. In question number 13, we are given that y of n is equals to, y of n is given to be y of n minus 1 and plus 5x of n for n greater than or equals to 0. We have given that y of n is y of n minus 1 plus 5x of n greater than 0, and it is also given that the value of y of n for n is equals to minus 1 is 2. It is given that y of minus 1 is 2. So now it is also given that summation from k is equals to 0 to 3 x of n is equals to 6. Summation from k 0 to 3, it is x of k is equals to 6. Then the value of yn at n is equals to, I have told you in Instagram group while the exam was going on, that you have to find the value of the signal y of n at n is equals to 3. So this question will not go to MTA. You have to find out the value of n, y of n at n is equals to 3 is what. So now it is a numerical answer type question. If you see here, y of n is given by this difference equation only for n greater than 0. Therefore, greater than or equals to 0. Therefore, if you try to substitute, you have to find out the value of n at n is equals to 3. Therefore, if you try to find out the value of y of n at n is equals to 0, then from this relation, value of signal y of n at n is equals to 0, we have substituted y of 0, then it is equals to y of n minus 1, that is y of 0 minus 1, that is y of minus 1 and 5 times x of 0. Is it right? We have written y of minus 1 plus 5 times x of n, and we are writing equation for n is equals to 0. Therefore, it is 5 of x of 0. Now we have given that this value is 2. Therefore, it is 2 plus 5 x of 0. Now, if you substitute n is equals to 1 then in this equation, then y of 1 will be y of 1 minus 1, that is y of 0, and we have obtained the value of y of 0 already. So we can write y of 0 as 2 plus 5 times x of 0. It is what? We have substituted n is equals to 1. This term became y of 0. Therefore, we have substituted y of 0 value from here, and now we have to write 5 times x of n. We have substituted n is equals to 1. Therefore, this value will be 5 times x of 1. Again, if you have to find y of n at n is equals to 2 from this equation only, so then y of 2 will be y of 2 minus 1, that is y of 1, and you have obtained y of 1 as this value 2 plus 5x of 0 plus 5x of 1. It is y of 1. Now you have to substitute n is equals to 2 here, so the term will become 5x of 2. Now for the last time we are taking the value and we have to find y of 3. Then y of 3 is equals to, we have substituted n is equals to 3. Therefore this term will become 3 minus 1 y of 2. And y of 2, the value is this 2 plus 5x of 0 plus 5x of 1 plus 5x of 2. It is y of 2, this much value. And next term will be 5 times value of x of n, and we have substituted n is equals to 3, therefore it will be 5 times x of 3. So now we have obtained the result. Value of y of n at n is equals to 3 will be the value of this function, and this can be written as, if we see here it is 2 plus, it is 5, if we take 5 common, then it is going to be x of 0 plus x of 1 plus x of 2 and plus x of 3. So you can also write it like 2 plus 5 times summation from k is equals to 0 to 3 x of k. It is nothing but x of 0 plus x of 1 plus x of 2 plus x of 3. And in the question, we have given that the value of this summation 0 to 3 x of k is equals to 6. Therefore, finally you have got the result y of 3 is equals to 2 plus 5 into the value of this summation is 6. Therefore, 30 plus 2, the value of y of 3 is 32. And it is the correct option for question number 13. So, correct option for question number 13 is 32. Now, we are left with 2 more questions. Just take it here. So, the next question is question number 14. When we will be studying further chapters, then we will include such type of questions, especially in case of Z transform. You can see the different methods to solve these type of questions. But here we have given, consider a cascade of following 2 systems. Here we have given 2 systems in cascade. What we have to do nothing with this given information, as we are not going to employ the rule of convolution or rule of any transformation. So we just have to take the difference equations that are given to us. Here it is given that there are 2 systems S1 and S2. We have not yet studied about cascaded systems and what is the result of equivalent system. So here we have given it is input applied x of n, here it is v of n, and the final output is y of n. So now we have given difference equation for this system as this output of first system S of S1, that is v of n, it is given as 1 by 2 times v of n minus 1 and plus x of n. The next equation relating this y of n to this v of n is given as y of n is equals to 2a times y of n minus 1 and plus b into v of n minus b into v of n. And the third equation relating overall input and overall output, it is the overall difference equation for equivalent of these 2 systems. For the time being, we are not going to discuss that concept, but it is given that a difference equation that relates final output to the actual input y of n equals to x of n plus 3 by 4 y of n minus 1 and minus 1 by 8 y of n minus 2. Then we have to find out the value of a plus b is what? We have to find out value of a plus b is what? And we have already 4 options given. So now, if you see here, what we have to do, we have to, you can say that if we have to find the values of a and b, then we have to mold these 2 equations such that we can have an equation that can be compared with this given equation. Let us name these equations as 1, 2 and 3. So we have to form a difference equation which will relate yn to xn only without having any terms of vn. Then only we can compare that equation with this equation and we can get the values of constants a and b. Therefore, we will have to evaluate a plus b. So now, if you see from equation 2, y of n is related in terms of yn and vn, and in equation 1 you are having value of v of n. So what you can do, from equation 2 you can write from equation 2. From equation 2 you can write y of n equals to 2a times y of n minus 1 and plus b times v of n, and v of n is given at 1 by 2 this value. Therefore, you can write b by 2 v of n minus 1 and plus b into x of n. we have just substituted the value of v of n from equation 1 into equation 2, and we have got this result: y of n is equals to 2a y of n minus 1 plus b by 2 v of n minus 1. Now if you see, this equation cannot be compared with this difference equation, as this equation is having y of n terms, x of n terms, that is all right, but this term v of n minus 1 must be converted in terms of either x of n or y of n, then only you can compare with this equation, as it is not having any v of n terms. So now to eliminate this v of n minus 1 term, if you see here from equation 2 only, we have seen that if this equation is representing the value of y of n, we can substitute any value instead of n, but we will have to substitute that value on each of the values of n, for each value of n. Therefore, from this equation, if we want to have value of v of n minus 1, so if we replace n by n minus 1, then we will have here the term v of n minus 1, and that v of n minus 1 can be evaluated only in terms of y of n. Therefore, the problem that is occurring here, v of n minus 1 term can be eliminated in terms of y of n. And now then we will be comparing with this equation 3. So from equation 2, we are replacing n by n minus 1. If we replace n by n minus 1, then equation will become y of n minus 1 equals to 2a times y of n minus 2 and plus b times v of n minus 1. So if we want to have the value of this term b into v of n minus 1, then it is equals to now y of n minus 1 and minus 2a times y of n minus 2. So now if we have to substitute the value of v into n minus 1, then we can use this term. So now coming to equation 4, let it is equation 4, then we substituting value of b v of n minus 1 from, let it is equation 5, from 5 to 4. We are substituting from value from equation 5 into equation 4, and now this equation will become y of n equals to 2a y of n minus 1 plus, it is b by 2. We just have find out the value of b into v of n minus 1. So we will have to take 1 by 2 into the value of v of n minus 1 is given as y of n minus 1 minus 2a y of n minus 2. So it is y of n equals to, we have written this value, and this term is left plus b times x of n. Now if you evaluate further, then y of n can be written as, see here also is the term y of n minus 1, and here we are having the term y of n minus 1. So the total coefficient of this term y of n minus 1 will have a total coefficient, that is 2a plus 1 by 2. 2a from here, and for this term the coefficient is 1 by 2. So we are having 2a plus 1 by 2 times y of n minus 1. And the next term will be this 2 and this 2 will get cancelled, minus a times y of n minus 2 and plus b times x of n. So now you can see here that we have obtained signal y of n in terms of y of n minus 1, y of n minus 2 and x of n, which is not having any v term. Therefore, now this equation, let it is equation 6, now this equation can be compared with the given difference equation, and for simplicity we can write the given difference equation here. Given difference equation is y of n equals to x of n, we can write x of n here also, x of n plus 3 by 4 y of n minus 1, 3 by 4 y of n minus 1, and then minus 1 by 8 y of n minus 2. So it is the given equation, and it is the equation what we have obtained. So simply we have to compare coefficients. So if you compare coefficient of y of n minus 2, then you can directly get the value of a, and you can compare x of n coefficient, then you will directly get the coefficient b. Here coefficient of y of n minus 2 is a with minus sign, and here coefficient of I minus 2 is 1 by 8 with minus sign, therefore the value of A is 1 by 8. So after comparing equation 6 and 3, A is equals to 1 by 8. If you are not satisfied with this value A is equals to 1 by 8, you can check from these two values also. If 2A plus 1 by 2 equals to 3 by 4, it is 3 by 4, then you can write it is 8A is equals to 3 minus 2, that is 1. Therefore, A is equals to 1 by 8. You will be getting the same answer, that is A is equals to 1 by 8 if you compare these two coefficients also. But no need to compare, as simply you can see from here A is equals to 1 by 8. And the coefficient of x of n is 1 and here the coefficient of x of n is b. Therefore, the value of b is equals to 1. Therefore, we have to find A plus b, that is 1 by 8 plus 1. Then it is going to be 9 by 8, and accordingly option B for question number 14 is correct. So the correct option for 14 is B. Now the last question, and we have seen the basics of this question in the last session. It is, we have to evaluate the value of integral I, that is integration from minus infinity to 0 2t plus 1 into del of t square minus 9 dt. So whenever we have seen that there is any function in the bracket of del of t which is having multiple roots, more than one roots, then this term can be evaluated as, we have seen that del of t square minus a square is equals to 1 upon 2 times mod of a del of t plus a plus del of t minus a. We have seen this. Similarly, if we applied this concept and find out integration from minus infinity to infinity, signal f of t into del of t square minus a square dt, then this result came out to be 1 upon 2 times mod of a. Here we have f of plus a and plus f of minus a. So we have to find out the values, as this impulse is occurring at t is equals to minus a and this impulse is occurring at t is equals to plus a. So when you substitute this value, then you have to take this signal f of t at t is equals to plus a and f of t at t is equals to minus a. So if the integral limits are minus infinity to plus infinity, then both of these terms will be taken into picture. But if you have taken limits from 0 to infinity, in which if t is equals to minus a point will not be included, then you must have to remove this term f of minus a. Similarly, in this case, if limit is given from minus infinity to 0, it means that this impulse which is going to occur at t is equals to a will not be present in the given interval. Therefore, this term, which is, if this term is absent, then there will be only f of minus a term, because f of a will be 0 outside the interval. It is, this impulse is occurring outside the interval. We have written f of a due to this impulse, and f of minus a is written due to this impulse, as it is occurring at t is equals to minus a. So the value of this function, this integral, is equals to, it is our function f of t, then this value of total integral is equals to 1 upon 2 times mod of a, and a is value having 3. 1 upon 2 times mod of a into f of minus a only, and minus a is what? Minus 3 only. So we have to find out the value of this function f of t at t is equals to what? Minus 3. Therefore, the value is going to be 1 upon 6 into, if you put minus 3 here, then minus 6 plus 1, that is minus 5. So the correct option for this question is minus 5 by 6, and if you convert it into decimal, then you are going to get minus 0.833. So it is the correct option for question number 15. So we have done with this paper. I have never solved it before, so it may be possible that I have committed some mistake. Then you just you can ignore it. You just have to take the concept from these questions. Then whenever in future, if you are facing such questions, then you will try your give your best attempt to it, having full confidence that you can definitely solve these kind of questions. So up to test 2, we have discussed 30 questions on the basics till impulse function, and you can say up to even and odd function. So in the next live session, we will be starting classification of signals, or you can say different types of signals, which will include periodic signals, Then we will move to power signals and energy signal, and that discussion are really important. As you can see, we have taken a question of in combat, in which we have discussed the energy in case of overlapping functions, and we have taken almost similar question that have occurred in GATE 2020. So it is, I have never said to you that whatever we are taking here, it is going to come in your exam. But definitely, exam, if the syllabus of the exam and syllabus of this lecture series is same, then definitely the questions are going to coincide in different forms, not in direct way, but indirect way, definitely you will be having such kind of problems. So just I want to say all you self-studying students that there are lectures available on GATE Academy Plus channel or basics, and we are trying to upload these lectures in English also on this GATE Academy Global channel. But till then you can refer these GATE Academy Plus channel videos, and then you come to GATE Academy channel, where this series GATE and ESE live series are going on. Additional concept that you will be having apart from GATE Academy Plus will you will feel sufficient for preparation of GATE or ESE any exam. And when an environment that you will be creating, if you will be increasing in mass, then it will motivate me to move to 30 questions test instead of 15 question test, and I will be more regular, I will be more focused and more motivated. So just stay with us, stay connected, and let me have your suggestions please, how we can improve this series. I am repeatedly asking you for this, but you are not yet given any suggestion from your side. One suggestion I have got that we should go for Google form to submit the results, but we have not implemented that yet. But I want to have your suggestions that how we can make the series most effective, so each of the student can feel themselves connected with us. Therefore, if it will be, then it will be the better for society and for all of us, and it will be more motivating for us. So we are ending this lecture now. If you have any queries, then please post that in comment section. And if you don't have the link of Telegram group where these tests are conducted, then I will comment that link in the description also, and in the comment section also you can get that link from description. So just stay motivated, keep trying your best. All the best. Thank you so much.